So hello friends, welcome to Suraj Ke classes once again. Today our topic is medium voltage drives. So in this section what we going to cover. So this is the medium voltage drives and how these drives are made. Actually we all of know what is the principle, what is the philosophy, how these drives work. We can already cover these topics into the category where we learn it in our college times. But when it comes to the medium voltage drives, which is having rating of 1.4 kV to 13.8 kV, so the topic is going to be very different now. So now let's start. So this is the topics index. In this, what we're going to cover this medium voltage VFD vendors first. What are the major vendors? Then features accordingly. What is the requirement of client side, and how you can fulfill those requirements. Then assembly parts. What are the assembly parts of these big drives? Then again, what is the drawings and how you achieve the approval, and then manufacturing stage obviously, then the inspection stage, then the final the dispatch stage, or the you deliver it to the client. Now firstly we will cover the major vendors. So there are so many vendors if we are talking about India or globally. So some major vendors list here: ABB, Siemens, INVT, Toshiba, then Hitachi. Toshiba is also known as T-Mac, right? And then Danfoss. So these are the major vendors. Of course, there are lot many other vendors too, but the major drives which are you know into industry, so these make drives are preferred. Then we have the features and accordingly requirements. So first of all, how these drives cover the voltage range. So it is into the range of 1.4 kV to 13.8 kV, right? These drives are used for applications like compressor, draft fans in many cement factories. Also for the crusher, crusher motor. So basically these drives are used to run the AC motors, whether it is induction or synchronous. So you can run both of these. Drives are designed to run induction synchronous motors. Basic assembly parts we are going to see in this slide. This is the first major part of any medium voltage drive, is that is transformer. And transformer is not that ordinary oil type transformer, but it is dry type of transformer. Then the inverter section is used, the signals or the voltage and current levels which are into AC form and coming at the end of okay, let me show you some principle of this. I will show you, no issue. So let me show you this. Okay, so first part is that transformer, right? So this is where you are receiving the three-phase supply. Obviously it is in AC form, so it is having signals like this, right? Then it goes into the inverter section where this AC is being converted to DC. So DC is in this form like this, and then this DC is again converted to AC through the diodes and diodes and inverters inside this inverter section. Actually there are multiple cells installed in this inverter. It may be of 30, 15, or it depends on the drive's kVA rating. So there are multiple cells which will do this task for you. It will again convert this DC to AC through IGBTs, and IGBT is the this is only controlled form of switch only. This is semiconductor switch only. So IGBT is having a gate signal, and this gate signal, when we give the pulse to this gate signal, it will trigger the all cells, and again that will convert it into the AC form. So this is how this cell is working. This is the cell working structure. Then again it goes to the AC form, then it can be given to AC motor, and this is how the drive operation happens. So this is what the philosophy, this is what the working of any medium voltage drive. But this transformer, again, this transformer is not a small part, it's a very big transformer which is installed inside the drive, and as per the requirement that can also be installed outside the drive, but with particular environment, you know. So that's what the thing is in this drive. Okay, let's move on to the next slide. This is IGBT cells are used into the transformer, then again the control sections having DC2 converting it, then again the control section which is used for accommodating the relays, the control card which is used to fire the IGBTs, and for the communication purpose like Profibus communication is there, TCP IP communication there, RS485 communication is there. So all those communications and relay, the contactors, control cards, so all these things are installed into one. I will also show you the outside and inside view of the drive. At that time we would be able to understand this properly. Now the closed view of this drive is this, and this is the open view. So now let me make it clarify for you how this thing is working. It's a very big thing, monster you can say. So how this thing is working, let me show you. So this is the this is again the closed view of the drive. So what I was telling you, this is the transformer part. You see the transformer is installed here, and you can also see here this is the transformer, right? And it is a dry type transformer. And then again the multiple cells that I was telling, this is the multiple cells. These are multiple cells which is installed into this section. This section is for cells or inverter, and this is again the control section where you see this screen, that is nothing but HMI, right? And there are several buttons like push button, and emergency push button. So everything is there. And at the top side you see these are nothing but fans with canopies. These are the canopies, and fans are installed inside these canopies, right, to protect it from outside environment, whether there is a dust or anything. So these drive also come with the IP ratings. IP ratings are also allotted to this drive, like IP41, IP42. So these drives comes with this IP ratings as well. And I was telling you this control section, and this control section you can see there are some control cards, there are some relays, contactors, MCBs, HMIs for communication. There is TCP IP, Profibus, and RS485. So these are some communication protocols which are used into these drives. And obviously this is your transformer. These are your fans. Two fans are for this transfer section. 3 fans are for, and fan redundancy also as per the customer's requirement. If fan redundancy is required, then back to back 2 fans are used. One fan is if it's not working, then another fan can work. So that way also many drives having function, right? So this is what the drive closed and open view. Now let's move on to the next slide. VFD drawing submission and approval stage. Obviously once you receive the order of any drive, the first thing that can one industry can do, that is to submit the drawings of particular drive, because it's it's not a very small thing. It's not a small thing, it's a very big size of drive. So there are lot many signals, lot many wiring work that is done into this drive. So it is not possible that the drive can be drive can be a default or with coming up with the prototype kind of, but it is customized product. It is not the regular product. Like regular product you see when you purchase any car or any transformer starter. So in those the things are very freezed in freezed manner, and it is not going to be changed. But in these drives lot many signals can be changed, lot many things can be customized. So here you need to submit the drawings. And in these drawings, see what things we generally submit. So majorly the common drawings that is submitted by any of the company, any VFD drive manufacturing company, that is VFD GA, that is general arrangement drawing of the drive. Like in this, that is what includes the drive's dimensions, drive's weight, what is the weight of drive, what is the dimension, what is the length, what is the height, what is the width. So that kind of dimension is covered into the drive. And again, wiring is submitted. Wiring means how many signals are going from out of control card, how the transformer, what are the signals that are going out of this transformer, how many cells are connected, and which wire is going, what are the points of connection of those wires. Then again, the data sheets. Data sheets majorly covers the drive ratings, drive type, drive if any it is any having temperature class or anything. So that is covered into the drive this data sheets. So these things are covered into this data sheets. Like some companies also provide the transformer data sheets as well. And quality plan, that means the once the drive is ready, that time on which parameter the drive is to be tested, because these drives also include the customer inspection. Customer visits the vendor's place, and he or she would inspect the drive. So how this you know how these things to be done, so you should have a particular quality plan. So these all documents are enclosed and submitted to the client for the approval purpose. And so this is what the document list which is to be submitted to client, obviously for the approval purpose, right? So the next stage that comes in the drawings review. And so the next thing that is to be done, that is the process from client side. Now the vendor's work is now completed. Vendor has to do nothing after the submission of drawing. They can just take follow-ups from the client for the drawings review. So it is the client's verification on drawings as per the requirement, whether it is sufficing the requirement, whether it is as per the discussion that held during the order finalization. So that those things are covered into the drawings review. Then finally, client approves the drawing. So final approval is given by the client after reviewing the drawing. There may be a stage where client submits the commented drawings. Maybe it can go up to 2, 3, 5 or 6 revisions or 7. That depends on the client's requirement. There are so many things which are included in this, like when you receive the order from any client. So there may be a end client also. Means from the party from you are receiving the order, is it is not the end user. Maybe it is having some other user, or maybe the from the party you are receiving the order, it has another user who is going to use the drive, right? So that way it delays the process. Means the comments you are receiving from your client, and also the client, your client is receiving comments from his client. So this way it can delay the process, and that is why this stage is very much important. Then again, we are going to now, once we have the approvals on drawings, we would definitely move on to the next stage, that is the VFD manufacturing stage. Now in this stage, the first thing that one vendor would do, that is the material ordering stage. During the submission of drawings, there would be, submission of BOM also, bill of material. So according to that bill of material, according to the approved drawings, the particular vendor would order the materials. Or if he or she or any vendor has the in-house production of these materials, then there is no need to order the material, because if the vendor has everything in-house, like transformer, control cards, cables, MCBs, contactors, relays, inverter cells, everything, if the vendor has in-house, then there is no need to order the material. That is why this process depends on the vendor. The next process is material readiness. Once every material is ready at your hand, then you just need to assemble it. You just need to assemble the drive, like there are section in the drives, like inverter section, the transformer section, the control section. So he has to assemble all these sections, and once he assembles all these sections, after the final assembly, the drive is ready for the customer. But one thing that vendor need to ensure is to uh, internally test the drive as per the customer's approved quality plan. So the testing requirement document that we submitted to the client, that was the quality plan, and that quality plan also needs an approval. Once the client approves that quality plan, the customer will internally test the drive as per the quality plan, and then the customer would submit the drive to the then raise the inspection call to the end client for the drives inspection. Now next, the VFD inspection stage. What things are covered into this stage that we are going to see into this slide? That before raising the VFD inspection plan, that vendor has to ensure that drive is internally okay. So the vendor would internally test the drive, then the customer's requirements are sufficed or fulfilled, then the inspection call would be raised. So what testing would be covered into this? What are the what are the tests that are covered into this that we are going to cover? See, first the bomb verification. These are some common, it is not dependent on any company or any industry, but these are very common, tests that are done. Bomb verification, like the parts which are installed into the drive, the customer would inspect those parts and verify it as per the approved BOM list. Then no load testing is to be done, like if motor is there, then no load, on load test if the motor is available there. Then functional testing, HVIR, high voltage insulation resistance test. So these are some common tests which are, to be performed on drive during inspection. Then there are some type tests like efficiency, power factor, harmonics, noise. As per IEEE 519, the harmonics should be less than 5%. So these tests are used on drives for the harmonics, right? And for efficiency and power factor, these are also type tests. Noise is also a type test. So these are some type tests which are to be performed on drive. Then there are also many clients who require the combined testing. Combined testing means the actual motor or the actual application load, like I'm calling it motor, obviously motor, then that is to be connected to the drive, and that is to be tested. Okay, so this test is performed in order to observe that the drive is okay with the actual loading condition, drive is okay. So that is performed. Many clients having this requirement. Next slide, we are moving to the dispatch stage. It is also a very important stage. After the VFD inspection actually covers, many times the client visits your place. Many times it happens that client is, not available. Then that time it happens that TPI, you can say third party inspector, also inspects the drive, and there are so many things then that can be done during inspection. After the inspection, there are many observations which may come from client side for the particular drive. Vendor has to take care of all these observations, and accordingly vendor can submit the compliance for that observation. After the submission of compliance, vendor now asking for the approval on those compliance, and then after the drive can be dispatched after receiving the dispatch clearance from that particular client. Now one big question can come to anyone's mind, that how much time is required for after completion of all these processes, and after completion of all these stages. So I will show you how these drives are actually, what is the time required for the completion of preparing one drive. So for this documents, drawing and submission and approval stage, obviously any type of engineering team working in any industry, that is actually a very variable parameter. But after the order finalization, it depends on the engineering team's strength. Also it depends on the client's requirement, how many things the client has asked, because many times what happens, like along with the drive, you need to supply the VCBs, that is vacuum circuit breakers. You also need to supply the isolators. You also need to supply the PLCs, programmable logic controllers. Also you need to supply the LCS, that is local control station. It also comes flame proof type. So there are so many other items that you need to supply along with the drive. So not only that, but also for the particular drive, there are so many things, like client requires the documents in particular format, so it takes much time. So after all this, the conclusion is it may take from 1 week to 4 weeks for the submission of drawings only, right? And then again, after submission of drawings, client may take 1 week to that is actually very much variable parameter. That is actually very much 1 week to you can say maybe client may take 4 months, 2 months, 3 months, 2 to 3 months also, or 4 months also. Many times it happens the client is taking more than a year, but that is obvious. That is again very rare. If client is having the decent requirement, then the client would provide approval within 1 week to, you can say, 4 to 6 weeks maximum. 1 week to 6 week you will have the approvals. So we are considering here the major. So we are considering here, let's say 2 weeks for drawing submission, then again for client's approval 4 weeks. Okay, 6 weeks are for just receiving the manufacturing clearance. Then again, manufacturing stage, how much it would take, let me tell you. The material ordering stage, it will also take some time. Actually this is also again a variable parameter. It will also take 1 week to 6 weeks. So here we are considering 3 weeks for material ordering. Material readiness, you can say 3 weeks, but if you don't have the in-house transformer, then it may take 8 to 12 weeks also for ordering the transformer and receiving it everywhere, because it's a big item. So transformer vendor also needs some time for this. Then again it is taking more than 12 weeks, or you can say material ordering stage, material readiness, you will definitely take more than you can say 16 to 18 weeks for this material ordering and everything, right? So we are considering as 16 weeks. Then final assembly and everything, that would be completed within 4 weeks. So 20 weeks time you need for the manufacturing, at least 20 weeks time, right? And then again we have already covered 6 week time for what, drawings submission and approval. Then 26 weeks time is required for the particular drive readiness. This is a very you cannot take it as granted, but it is very general timeline that I am providing you. It is very general, so there is nothing, it depends on industry again. If you have the in-house transformer, then it won't take 26 weeks. It may take just 15 to 17 weeks also. If you have in-house everything, every material, then it will not take more than say 15 to 20 weeks. So 26 weeks you can consider as of now for a general timeline for the you know, drives readiness. So in month, if you are converting it into the month, then you can say 6 to 7 months time you have to take on from the drawings, submission, from the day one of drawings submission to the last day last day means drives readiness, it will take 6 to 7 months. So this is what the timeline is. So this is what the dispatch stage, and then again the dispatch documents are to be submitted to clients. So thank you so much for watching this video. I hope you enjoyed this, and these are our contacts where you can reach us. So thank you so much. If you still have any doubt or anything, you can just comment us in below. We would definitely take care of those and come back to you. Thank you so much. Take care.